All right. Perry Live from Transform Your Kid here. And this video is for parents who teach their own children math or tutors who are working with children in math. In today's video, I'm going to share with you, it's going to be a little bit controversial because it depends on your personality. Are you the sort who wants to follow what other people are doing so that you don't stand out and be different? Or are you the sort that prefers to get results than to do what other people do because, that's the right thing to do? For me, I'm more of the second category. To me, if you can get a result faster, easier, and more effectively, then forget what other people are doing, forget what even school is teaching, and just use what's most effective in helping yourself or in helping the child. The most important thing to me is to help a child believe in their ability to be successful, right? I repeat that. We want to help the child to believe in their own ability to be successful. And how do we do that? We do that by removing as many roadblocks as possible that makes them feel like, oh, I can't do this, oh, it's too hard. So there are going to be children who have different abilities in math, right? We talk about the multiple intelligences, and the language of logic is one of those intelligences that may or may not be a strength or an innate talent for a child. So, but does that mean they can't do math? No, it's not. Because we know that ability is a function of talent times effort times time. Ability is the function of talent times effort times time. What it means is if someone is less talented than another person, all they got to do is spend a little more time, put in a little more effort during the time spent in practice. Excuse me. And they're going to get better. So in this video, I'm going to share with you this, oh my God, this pain that a lot of parents and tutors have to go through, which is teaching long division. It's totally abstract. It does not make sense to most of the children growing up, unless they've got a language of logic down easy for them, or they just memorize it. They just have a knack for memorizing algorithms, but most of us don't, right? It's got to make sense, or else we won't remember it or even use it in the first place. I found that using this technique increases the motivation in the child to do the math of division because it makes them feel that, you know what, I can do any division, just give me any. Prerequisite to doing this kind of division is, I'll talk about that later. Let's talk about the conventional way of doing long division that you're going to see in all the math textbooks, and all the teachers are doing this. It's not their fault because they're going to do what the masses are doing, or else the child, if they learn something different and they go into the next level, the next teacher will be wondering, like, why haven't you learned this method yet? Didn't the previous teacher teach you that? So it's not the teacher's fault. Even if they know a better method, they do still have to teach the conventional method first. All right, so don't blame the teacher. Just be more resourceful as mentors and as teachers. Yeah. Here is the conventional method. Right? Not a problem, right? And then, boom, they get this. If the child has not mastered the multiplication table, or if he or she just made a careless mistake, for example, boom. We know that once you subtract, that number there cannot be bigger than the 4. Now the child will have no idea why that's the case. But we know because we want to make sure that this algorithm is like abided by, right? You don't change the algorithm. So the problem with this is that the child seeing this would think there's nothing wrong with seeing this, and then they bring down the next number, which is a 2, and now they've got a problem because what? How did this happen? How did the 92 appear? How do I get from 4 to 92? And they get stuck, they get disappointed, they get frustrated, they get bored, they get angry with you. A lot of different things can happen. We all can relate to that. This is another method that I suggest. After they've learned this and they're semi-successful or not too successful with this, use the other method to reinforce the concept of long division. The prerequisite is that the child must be able to do 2 multiplication tables, 5 multiplication table, and 10 multiplication table. 2, 5, 10. If they can do all that, they don't have a problem with multiplication tables. They don't have a problem with this division method. So here's how it looks like. Okay. Same question, but this time we're going to do this. Looks weird, but don't worry. I give them a story first. I say that you have 732 cakes and you're going to put them into boxes. These boxes can put in 4 cakes each. How many boxes do you need? So imagine a table, a huge table with 742 cakes all together, and you got to put them into boxes of 4. So first, we know how many boxes we can put in at first because we're going to slowly put them into boxes, right? So we're going to try by putting it into 100 boxes first. Most students at primary 3 and primary 4 can do 4 times 100. Remember, it's 10, 5, and 2 times tables. If they can do 10, 5, and 2, they can do 100, 50, and 20. If they can't, train them in that first, okay? So if I put them into 100 boxes, I would have packed away 400 cakes. How many cakes are left on the table still? Let's find out. 332. I know I can't use 100 boxes anymore because 100 boxes puts away 400 cakes, but I only have 332 cakes now. So what do I do next? I've got to use less boxes. The next number after 100 is to go down to 50. 50 boxes gives me 200 cakes. I can pack in 200 cakes now. I put away 200 cakes and I want to check how many cakes are left on the table. 132. You see where I'm going with this, right? So let me scroll down, make sure that everything can be seen. We can't use 50 anymore because 50 boxes puts away 200 cakes. They know they have got to use lesser cakes. Even if they do it wrongly, even if they put 50 again, they will realize they cannot subtract. That's not a problem anymore. So they don't have to reduce. See, 2, 5, 10 multiplication table. 20 and 4 makes 80 cakes. Take away that. They've got 52 cakes left on the table. Now they use 10 boxes to put away 40 cakes, and they have 12 cakes left on the table. Now, most students will be able to know that 12 cakes is 3 boxes of 4. But even if they don't know this, they know that if they know the 2, 5, and 10 multiplication table, they can do this, right? So, what's next? Where's my cursor? There it is. Let's say they use 2 boxes now. They know that 10 won't work, 5 won't work. 2 boxes, puts away 8 cakes. They have 4 cakes left, and now it's just 1 box. Because every box can put 4, I've got 1 box to put in these 4 cakes. And voila. Let's show you everything, what has happened so far. And they can see that there is no remainder. No remainder, which means all the cakes have gone into boxes. And they look at the right-hand column and they can just add up the number of boxes they have used as the number of boxes, basically. They just add these all up. They can add, not a problem, right? And then right at the bottom, there's no cakes remaining on the table, so the remainder is 0. And that's it. Very little chance for careless mistakes. Very logical that you can attach to a story to use this multiplication, to use this division method. All right, this is Perry Lai from Transform Your Kid. Now, this is just one of those methods that I've discovered, and to help your child, to help the child that you're working with believe in their ability to succeed in math. That is so important. Help them believe. Use methods that are easier for them to understand. Help them to use thinking and mindsets that gives them that belief. And if that's something that you want for your child, then go ahead and message me on my Facebook page, which is Transform Your Kid Facebook page. Message me there. We can talk and I can see what I can do with you or your child. Yeah? Perry Lai, talk to you soon. Bye.